Lesson 5.4 deals with coordinate geometry, so we're going to be looking at some points in a plane. And this is really kind of cool. In computer graphics, so some of you actually might want to be a graphic designer someday. In computer graphics, a coordinate system is used to create images from simple geometric figures to realistic figures that are used in movies. If you look at this penguin over here, you can see it is somewhat of a warped looking XY axis. It's really, there's an XYZ axis in here, which you'll learn about in higher level math. But they've taken this computer graphic and they've generated it to make this realistic figure in the movies. So we're going to look at properties of coordinate planes that can be used to find information about figures in the plane, such as whether opposite sides are congruent. And remember, to be congruent, it means they have the same measure. Okay, so the first thing we're going to do is we're going to graph the polygon. Remember, a polygon is a many-sided enclosed shape, and the sides of the shapes are edges, which are segments. They're line segments. And we're going to give the most specific name for each of these polygons that we can. So we're not just going to say, oh, it's a quadrilateral, oh, it's a pentagon, etc. We want to get as specific as we can. So I have point S is -3, -3, and I'll put an S there. T is -3, 4. And U is 4, -3. And I will go ahead and connect this. Whoops, let's sometimes, oh, there we go. My board is a little bit slippery. So when we look at this, and I'm going to go ahead and make it so that it's not white. My inside needs to be see-through. There we go. When I look at this, I can tell that it's a triangle, but I need to be a little more specific than just it's a triangle. I can clearly see that this is coming together at a right angle, so I know so far that it's a right triangle. But I need to know, is it a right isosceles triangle? Or is it a right scalene triangle? So what I need to do is I need to figure out, if it's isosceles, remember two of the sides are the same. So I need to figure out, these are the two sides that look the same to me, ST and SU. So I'm going to actually figure it out. It's nice that they're giving me vertical and horizontal lines to start out with. So from S to T, it's 1, 2, 3, 4, 5, 6, it looks like 7. And from S to U, it's 1, 2, 3, 4, 5, 6, 7. So I know that this is a right isosceles triangle. So a right isosceles triangle. That's as specific as I can get. I don't need to find the distance from T to U because I could not have this be an equilateral triangle. Remember, an equilateral triangle, all three sides and all three angles are the same. But in an equilateral triangle, all three angles are always 60 degrees, no matter how big or how small the triangle is. So I can stop right here. It's a right isosceles triangle. Next, I've got 4 coordinates, so I know that this is at least a quadrilateral. So I have point M is -1, 2, and N is 2, 0. Q is 2, -4, and P is -1, -2. So I'll go ahead and connect this. And it looks like it's a parallelogram. Remember though, on a parallelogram, both pairs of opposite sides are congruent. So we have to see, are both pairs of these opposite sides the same length? Well, it's pretty easy to figure out M and P, N, Q. We can just count 1, 2, 3, 4 here. Oops, let me change colors. There's 4 here, 1, 2, 3, 4 here. But now I need to figure out the distance between m and n. Good thing we learned that distance formula earlier in the chapter. Actually, it was the last chapter we learned it in, chapter 3. So I'll recall this for you. The distance formula, we subtract the x's, square them, and we subtract the y's, square that, add it up, and take the square root. So right now I want the distance from m to n. And this is how I show that I'm looking for the distance. Well, my m and n coordinates are nicely put up here for me, so I'll just fill in the blanks. Remember I talked before about making ourselves a little template. So my x's are -1 and 2, so -1 minus 2. And our y's are 2 and 0, so 2 minus 0. -1 minus 2 is -3. Notice I'm keeping the -3 in parentheses. 2 minus 0 is 2. Remember, be smarter than the calculator. -3 squared is not -9, it's +9. 2 squared is 4, and so I'm going to get the square root of 13. Right now I'm just going to leave it as that irrational number, square root of 13. Because they're not asking me what is the actual distance here. I just want to know, is it the same as PQ? So I will figure out the distance from P to Q and see if it's the same. So again, I'll set up my template. And from P to Q, I get 2 subtract -1. For the x's, and the y's are -4 and -2. Don't forget you add the opposite when you have the double negative here. 2 plus +1 then is 3 squared. Oops. -4 plus -4 plus 2 is -2 squared. This is giving me the square root of 3 squared is 9. -2 squared is +4. And looky here. I end up with the distance from P to Q is also the square root of 13. So they're not all 4 equal, so I know that I don't have a rectangle. But I do have 2 pairs of opposite sides that are parallel. So this is a parallelogram. A parallelogram. I am not just saying it's a quadrilateral, it's specifically a parallelogram. I spelled parallelogram wrong. Ugh, goodness. Just because I'm a math teacher doesn't mean I shouldn't know how to spell. So let's spell this right. Parallelogram. Please make sure that you fix that spelling on yours. All right. Now here, I just went over this. But it says, recall that if a quadrilateral has 2 pair of parallel sides, then it is a parallelogram. You can also classify it as a parallelogram by showing that both pair of opposite sides are congruent. I just went over that. So we can use this set of information to also, and other properties of geometric figures to determine the coordinates of a missing vertex. So here we have triangle WUV. Well, I only see W and V. But it says that there's a right angle at W and that WU is 5. So if there's a right angle at W, I'm going to have a right angle here, and WU is 5. Well, I can have 2 possibilities here for my coordinates. I can count up 5, 1, 2, 3, 4, 5, and there's a right triangle. So the coordinates of U could be -2, 6, or I could count down 1, 2, 3, 4, 5. And again, I made right angles in both spots. So my coordinate of U could be -2, 4. So this is two possibilities here. So this is find the coordinates of each missing vertex. So you could be here or here. Let's try this one. It says quadrilateral JKLM is a square. I know for the square, all four sides have to be equal. So this side, this one's pretty easy. I just have to line it right up here. So whoops, let's make that look a little bit better. I just draw it right here and right there. And I just want to double check and make sure that my sides are the same. They look like they are, but it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, and then these are the same across from them. So I'm missing is JK, I'm missing coordinate L, so this must be L, and it's 4, negative 5. Okay, next we have a definition that we need to fill in. Actually, it's already filled in for you, but let's look at it. Whoa. And that's a midpoint. The midpoint, so underline this please since I didn't make it a fill-in. The midpoint of a segment is the point that divides the segment into two congruent segments. So if we have segment AB, this M is the midpoint because AM and BM are exactly the same. This point cuts it into two. So that's what's happening here. Now to do the midpoint formula, it says the coordinates of the midpoint of a segment can be found by averaging the x coordinates and the y coordinates. When you average something, it's taking the mean. You add them up and divide by the total. Well, here we have 2 points, so you'll add them up and divide by 2. So if we look at the numbers, we take the x coordinates. Here it's 1 plus 3, divide by 2. 3 plus 5, those are the y coordinates, divide by 2. When you actually do it, this is what you get. And I want you to circle this midpoint formula. This is hugely important. Why don't we even write it down here again? So my midpoint formula, I take x1 plus x2, divide it by 2. This is the one formula where we put the x's together. Normally, well, I guess our distance formula, we did that too. When we look at the slope formula, it's x's with y's. No, it's not. It's x's with x's. I guess I want to say this is the formula where x comes first. So and then we have y1 plus y2. We're adding them and dividing by 2. Let's do a couple of these for as an example to find the midpoint. So here we're finding the midpoint of segment xy. So I'm going to take the x coordinates, 1 plus 4, divide by 2, comma, the y coordinates, 2 plus 5, divide by 2. And now I'll just do the arithmetic. 1 plus 4 is 5 divided by 2. 2 plus 5 is 7 divided by 2. And we can turn these into decimals. 5 divided by 2 is 2.5. 7 divided by 2 is 3.5. So the midpoint is right here. If we were to draw this as a segment, this would be right in the middle. Let's try this one, midpoint of ST. So I have negative 8 plus 2. Those are my x's, divided by 2. 6 plus 4, divided by 2. Those are my y's. Negative 8 plus 2 is 6 over 2. 6 plus 4 is 10 over 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So the midpoint is 3, 5. And then finally, let's look at one where they actually give us a picture. So point A is the point negative 3, 1, and point B is the point 4, 3. Ooh, 4, 3. So I want to find the midpoint of AB. So it looks like it's right around in here, but I don't want to just guess. So I'll go negative 3 plus 4 divided by 2. Those are my x's. 1 plus 3 divided by 2. Those are my y's. Negative 3 plus 4 is 1 over 2. So there's a half. 1 plus 3 is 4 over 2. So I can leave this as 1/2, comma 2. And 1/2, 2 is right about there, which is what I said it was about. But we needed to make sure that we just didn't guess at it, that we actually calculated it. All right, here's your lesson 5.4. If you want to start at page 215 to 217, problems 1 to 21 and 25 to 27.